Hello. So here we need to find the volume of the solid obtained by rotating a region that's bounded by the quadratic curve y is equal to x square minus 2x and a line y is equal to x. About the line y is equal to 4. So it will look something like this. This is a line y is equal to x. This curve, quadratic curve will go here and meet somewhere here. So this is the quadratic curve y is equal to x square minus 2x. Okay. And this is a line y is equal to x. And this is something y is equal to 4. Okay. So it is rotated around this. It would something look like this. Let's see. One. So it will be something like this. Just straight line. So this curve, this, this, this. So the new solid will something look like this. Here they will meet at some point. Okay. So we are using, so as we are rotating around the, rotating about the horizontal axis, we know that cross-sectional area will be function of x, and we'll draw a more detailed picture to give a good view. So this will be, these curves will look something like this. Now we'll make two discs or rings to get it. So this is how the two rings will look, or we will make two rings here. So now we know that inner radius here is not x. The radius of the inner ring is not x. It is the distance from the axis of rotation, which is this green line. So this is the inner radius, which is 4 minus x. Okay. And the outer radius is 4 minus x square minus 2x. This will be the outer radius of the ring from here to here. Okay. Inner radius is the distance from axis of rotation, which is this. This is the axis of rotation. Okay. To the inner radius of the ring. So, and the same way, outer radius is the distance from axis of rotation to the outer edge of the ring. So outer radius is 4 minus x square minus 2x. Okay. Okay. For the ring we are seeing here, we see that fx is negative. So when we'll subtract in this formula, actually 4 minus x square, outer radius is 4 minus x square minus 2x. Okay. So we see that when we in the ring shown here, we see that this actually here the value is negative. So it adds, so negative and negative multiply and it becomes positive and it is actually added to 4. Okay, so this value which is negative is added to 4 and that gives you the outer radius. And when this is positive, suppose here or here, it is subtracted from 4 and then it gives this value which is the outer radius. So now we have to find the cross-sectional area to get the volume. So area here of the rings is given by pi outer radius square minus inner radius square. Okay, so this is pi and x square minus 4x cube minus 4x square minus 16 minus 8x. Yes. So this gives you pi x4 minus 4x cube minus 5x square plus 24x. Okay. So this is the area. Now we have to find the limits and we have to see where they intersect. Like we have to find the points with this. So we have the graph, but if we can find it algebraically also. So the points of intersection we can get it by intersecting two graphs. Okay. So this is x square minus 3x is equal to 0. So x is 0 and 3. So the first ring is at x is equal to 0 and the last ring will be at x is equal to 3. So the limits are 0 and 3. So the volume is AB AX dx. So this will be pi 30 x raised to power 4 minus 4x cube minus 5x square plus 24x and dx. Now we integrate using the integration rule and the integration of x and 6x plus here we are just choosing this will give us 1 5 x 5 4 4 x raised to power 4 5 x cube 324 x square plus 2, and this gives 3 CL. Okay, so this gives you now the no meaning of putting 0 here, and this gives 3 raised to power 5 by 5, 3 raised to power 4, 5 by 3 raised to power 3 cube plus 12, 3, and this. And when we put everything in calculator, we get it 153 by. Thanks. So this is the volume